Hi, I'm Shahan, and I wanted to show you my work in Gaussian splatting. So Gaussian splatting is this 3D reconstruction method where you take a bunch of photos of a scene, for example of me standing here, and then you can turn that into kind of a 3D model. But it's not exactly a 3D model like a normal mesh, but it's a bunch of these 3D Gaussians, which are just little blobs in 3D space. You can kind of see all the blobs here. So right as Gaussian splatting came out, I got very interested in it, and I realized that you can edit these very easily because it's a very explicit representation. So I created one of the first Gaussian splatting editors of the world, which I actually believe I'm the first, but I'm not sure if I exactly was. So I took an open source viewer I found using JavaScript and WebGL, and then I added the editing features on top of it. So this is that viewer, and you can see I can like click to throw colors onto things as kind of like paintball. And then the cool thing is I can actually like come and just move my head up if you want to decapitate me for some reason, or you can even just like remove parts, and this creates a pretty fun demo. You can see you can just remove whatever, and other things are editable in the scene as well. You can just remove things. So then I got pretty interested in, just creating a lot of Gaussian splats. So I went around my campus, I questionably flew some drones, and I, captured all that I could. And I created these Gaussian splats on my campus. You can see this one is pretty good. It's on my campus. And again, you can do like kind of the coloring features and the other editing features. Like I actually really don't like this building because none of my classes are in this building. So I just like to just, remove that building. Yeah. So then, also, for example, you can see like every time I would go for a dinner with friends or something, I would always, go and, make a splat to kind of preserve it. So then I realized that to do the editing properly, you need to actually like have some semantic segmentation of the splats. Right now, the splats are just a bunch of blobs in space, but we don't know which one belongs to which object, right? So when I do this editing, I shoot a ray from the camera into the scene, and when it hits something, I get a big ball of things around that, and that's how I'm doing the editing. So that's when I realized we need to do some 3D semantic segmentation of the splats. But there was no research papers at that time about this. So I started doing some novel research, and I completely like independently drove this effort. I talked with a prof for like advising at my school, but it was like me actually driving all the research. So basically what I did was what I talked about, during training time, I did the 3D instance segmentation. So how I exactly did that is I used meta segment anything to segment the 2D training images of the splat, of like my training data. And then when I would do the training, just like you can train like features for the color and opacity, I added a new feature to every single splat, which is what instance in the scene does that splat belong to, and then during training time I would optimize that, and that worked pretty well. You can see like here, it's learned that these couches are like different instances, and that allows me to do like cool things like, I can just remove the background, or I can just like remove one of the chairs, or I can come and just move like one of the chairs around, and it's not like a big blob, but it's actually understanding which objects. And so this is like some novel research I did, and you can kind of see the code for it here, and I made a YouTube video describing all my findings and all of that. And it was all like self-driven. So, but then I really wanted to like make a faster editor, and I wanted to also like go deeper into the hood. So I decided to create my own Gaussian splatting viewer completely from scratch. So I started like from an empty repository, empty file, and I wanted to create my own viewer and with very little like external dependencies. So I created this project, which I call Rust Gaussian Splatting, where I used Rust and WebAssembly and WebGL to create this Gaussian splatting viewer. And I did a bunch of like cool things like using OctTrees and using a special type of sorting for rendering, and I'll go through some of them. And you can see the code for this. I started this project around 1 year ago, and I've been kind of working on it on and off in the free time that I have. So it's all written in Rust and WebAssembly. So this is kind of what the viewer looks like. And then the first thing I want you to notice is I'm going to do the editing again, and you see it's much faster. It's almost real time with like editing me. So the reason behind that is because I'm using OctTrees to be able to like store the scene. So I could click the Add Shahan button to add another Shahan. This is also an improvement to the other viewer. It has an Add Shahan button. And you can see this is how the OctTree looks. And I think this is my innovation. I didn't see any other real papers that really use OctTrees in this way. And basically how it works is an OctTree is kind of like a quad tree, if you've heard of that, or kind of like a binary tree, where basically in the areas where there's a lot of stuff, there is not many subdivisions, but in the areas where there is a lot of subdivisions, but in the areas where there's no stuff, there's no subdivisions. And this allows us to kind of like, and it's kind of like a binary tree, where it's like, but instead of only having two like children for every node, there's 8 children for every node. And by the way, this visualization and stuff is all again in the Rust WebGL kind of viewer. And you can kind of see, where there is, I'm like, standing over there, and I'm standing over here, and there's a lot of subdivisions in the OctTree, but in the places where I'm not, there's a lot less. And we could click the Add Shahan button. And then my viewers, I did a whole bunch of different experiments. So for example, I added bigger splats, and I also like this stuff like using the OctTree to generate shadows, and also for collisions to be able to like hit the walls and stuff. And then for example, this is in like a bigger scene of my house. You can again click the Add Shahan button to just add me right there. One thing is, for example, this viewer has some things that he can show you the under the hood, what's kind of happening. So you can see each splat is kind of like a, it's actually a 3D blob, but when you project it onto the screen, it becomes a 2D kind of ellipsoid. And so you can see what the splats are, and usually they're transparent, so there's this blending happening. And when I turn off the blending, you can see the splats more clearly. And then one interesting thing is, it's very important when you're doing Gaussian splatting rendering to go from like back to front, because that's just kind of how transparent colors work. It's like you need to do it in the right order. So the splat that's like farthest away from the camera needs to be thrown onto the screen first, and then the one that are closer needs to be thrown onto the screen so that colors are right. So the problem with that is every frame we have to do this sort algorithm where we sort all the splats back to front based on the the viewpoint of the viewer. And the problem is WebGL doesn't support like arbitrary kind of like compute shaders. So I had to do that sorting on the CPU, and I had to do a lot of like optimizations to make it fast. So for example, one thing I didn't use like something like merge sort. I tried it, but it was way too slow. So I actually used something called counting sort, which is kind of similar to radix sort, which allows this kind of like O of n time, and it's a bit faster. And so I can actually turn off the sorting. So if I turn off the sorting and then I look over here, you can see the scene is all like messed up because the things are being rendered in the wrong order. But then the second that I actually turn on the sorting again, you can see it's really clear. And also the OctTree is also, is taken into place in this scene as well. So that was kind of one pretty cool thing about this viewer is, the OctTree and the sorting, and yeah. So you can see this is some other stuff I did, like this is another scene on campus. And then I was talking with that professor that I was kind of in communication with, and he had this research that he was doing, which is Gaussian splatting infilling. So he was doing, filling in the middle of the Gaussian splats. So, and then he asked me, for this research paper, this CVPR research paper he was working on, he wanted me to build the live demo for it because he wanted to do a demo. So I actually used my viewer to build a live demo for him of his research, and if we did a demo presentation at CVPR this year, and you can see, I'm on there as well, and this was really fun. So I can show you what this was. So this is like, for example, a Gaussian splat of a cake, and then you can kind of hold down P and drag, and then you can split the splats into half. So it's really fun to play around with this and just do the splitting. And it's again my viewer, I wrote it completely from scratch, no external dependencies, nothing like that. And this is like, for example, a piece of bread. You can again, you can slice the bread. It's pretty fun. I still need to make it faster, but it's a pretty fun, and it looks pretty cool. And by the way, I didn't directly work on this, but the way the infilling works is he used diffusion to kind of generate a training data set of like what the inside will look like, and then train based on that. And it's kind of interesting what he did. And then you can see here, this is like an apple, and you can again slice the apple. And all of like kind of the Gaussian splatting work and nerf work I've done, is all just kind of self-driven because I'm just really passionate about like cool things. And it's not like I was like for a course or a class or anything like that. It's just I've always just been really interested in just creating cool stuff. So that's what I've been, it's all self-taught, all out of my own passion, reading all these research papers and learning how to do all this, and really excited to do more cool stuff in the future and to just work really hard. You can see this is of an orange, also very cool. And you can see here, my GitHub, you can see I have a lot of different types of projects, also like other graphic stuff, and of course the Rust Gaussian splatting viewer. Another kind of interesting thing about the Rust Gaussian splatting viewer is, I had to like, for example, write my own ply file reader because all the other libraries that I actually tried out were way too slow. And then I'm actually using this serialization library called Archive, which actually like serializes the splats and loads them really fast, and it's really cool. It uses something called zero copy deserialization, where it's like I prepare exactly kind of the buffer as it should be in the browser, and then when you load the page, it just loads that buffer directly into the Rust memory without having to like do any like sort of JSON parsing or anything like that. By the way, originally I was using JSON to store the splats, and it was really slow, so I had to make that faster. And yeah, but my favorite feature by far is the add Shahan button. You can go into all the seeds and you can add Shahan. But yeah, hope you enjoyed. Yeah, I need to still work on the scaling part. Hope you enjoyed this demo, and yeah, that's my work in Gaussian splatting.